Welcome to Akto's webinar on top 10 GraphQL security checks with Uri, our guest speaker over here. Just before we start, I want to let you know there's a poll. If you want to answer a question there, please answer. There's chat, there's Q&A. Feel free to ask anything that you want to ask. Today's session is completely going to be on GraphQL, so ask any question related to GraphQL security. More than happy to answer. All right, so let's start. Quick agenda. We'll obviously start with introducing our speaker, Uri. What is GraphQL? Why implement GraphQL security? So setting some context before we actually jump into the 10 GraphQL security checks. And lastly, how Akto can automate GraphQL security. So as you are in Akto's webinar, so we'll just talk a little bit about Akto as a product. How you can use it for GraphQL security. So let's start. All right, so we have Uri over here. I'm super excited to welcome him. He's a bunch of things, but he's everything GraphQL. He's like a huge expert, some 10, 12 years of experience in GraphQL. He's the founder of Guild, which is the largest open source group in GraphQL ecosystem. Sorry for the spelling mistake, but he's a board member of GraphQL Foundation. He's also governing board member of the Open API Initiative. So he's everything API and GraphQL basically. And I wanted to put this picture of you here because this has this very nice boundary, which according to me is GraphQL. Is that right?
Yeah, it's kind of it's a mixture of the Guild and GraphQL because we have we started from GraphQL and most of our tools are around GraphQL, but then we kind of grew also out of the space into, like you said, like an open API space and other API specs. So yeah, now we kind of like look at all the different APIs and also try to get the best out of each. And we also build tools that convert automatically between the different APIs. So from let's say from Open API to GraphQL, from gRPC to GraphQL, and it also taught us a lot about all kinds of cool ideas that you can have in one protocol and bring to another. So yeah, thanks for having me. Really excited to be here.
No, we are super excited to have you, Uri. Like, as you can see, guys, he just breathes, eats GraphQL. So this is going to be very interesting discussion. So before we give over to Uri, by the way, here we have Ankush, who I forgot to introduce. He is my co-founder and CTO for anyone who doesn't know him. I'll give a little bit of introduction of what is Akto. We'll discuss how Akto can do API security for you, but bit about Akto is it's the world's only open source proactive API security platform. It has the largest API security test library. We were founded in 2022, which is like 2 years ago, headquartered in SF, Twitter handle, and GitHub. Because we are open source, you can go to GitHub and check us out. Our mission is to secure every API before deployment. So we are doing API security in shift left way. So this topic, what is GraphQL? Before we jump into GraphQL security, I thought it's going to be interesting to just discuss, what is GraphQL and what is the difference between actually REST and GraphQL, since REST is the most popular just before GraphQL. So, but I'm not going to discuss this. This is Ankush who's going to discuss this. He's been like working with REST, GraphQL since, 13, 14 years. So I thought it'll be good to get a bit of intro from him on GraphQL. Let's start.
Yeah, thank you. Thank you, Ankita. And Uri, personally, I'm looking forward to this session for a lot of learning for myself as well. But yeah, and of course, I think pretty much entire presentation, you would be knowing more about GraphQL and GraphQL security than me. But yeah, just for starters, and this is personally, I feel like couple of huge advantages over REST. One is it's a single endpoint. That means I don't have to deploy backend every time I have to change my client or to change my query. That's like operationally, it makes everything like super easy because I don't have to I can just change my client side code and just work with a single endpoint. Subscriptions and that's like updates and subscriptions is again like a big advantage because it's inbuilt natively into GraphQL. It makes it very easy to use. Rest, you have to write like a whole pipeline, probably through WebSocket or something, to actually support live updates. Third point is, again, like becomes like the moment you grow a bit bigger, you would want like a very complete, exhaustive, automated API inventory. A big problem again in the REST world, where a developer has to either like manually maintain the API collections, but GraphQL, thankfully, a simple introspection query can give me the entire API documentation in one go. I can modify the GraphQL queries. I can, efficiency from an efficiency perspective, development efficiency perspective, it's great. I can change the query. I can request more and more documents. Again, all without changing the backend server side completely. Like just deploy the GraphQL server and you get all of this for free. And the queries are also like very flexible. I can request like multiple objects. If there are connections from one object to another, I can request like nested objects as well. So again, like all of these are like very for someone who has programmed a lot of like REST servers, these seem like huge advantages to want to switch to GraphQL. And I think, I'm not sure, like Uri, feel free to add, but if I've missed anything, or should there be some other point in the top 5 where GraphQL proves more advantages than REST, like feel free to add.
No, I think you made like a really good intro. I would add like from a higher perspective or point of view that like in a broader sense, for me, GraphQL is kind of like a declarative way to do things that we do in code with other APIs like REST. So that's how I always try to think about the equivalent of comparing them. And I'll also talk about it later in the other slides. But for me, for example, like, yes, it's a single endpoint, but the truth is, let's say if we compare how we would do that with REST with multiple endpoints, we would write some code that calls a certain endpoint, then gets the information, that then maybe calls another endpoint, gets the other information, then merges it in and combines it in a way that we want to render, let's say, to the screen of the app, and then we would render it. So with GraphQL, instead of doing all this work manually, I would actually describe it in a declarative way. I would put in a query how the query would look like, as similar as possible to how I would render the screen, like to the data structures of the screen, send it to the GraphQL endpoint, and the GraphQL endpoint will do that work for me. It will go and fetch the APIs, and it will go and merge them in the right way, orchestrate all the different calls, and send me back the results that I want. So it's not different, right? Like these things will still happen, just instead of writing it in code, because I'm writing it declaratively, the tools, which could be the GraphQL engine, for example, will do it automatically. So, we mentioned in this case, or I would write that code on the client that will call the different multiple endpoints and merge them, or that I will write like a controller in an MVC, right? Like in the controller, I would call one endpoint. The control will do all that work. It will call different data sources, merge the data as the client wants, and then send it to the client. So today, so for me, it's less around. It's more just around looking at what we currently do with REST and automating it and writing it in a declarative way. So that's for the single endpoint point of things. The real-time data thing that you said is really important. Again, like it brings this ability to watch for real-time updates. Like I can subscribe to an event that's the idea of subscriptions. I'm subscribing to an event, like the equivalent would be PubSub, just any PubSub. So GraphQL subscriptions can run on, like GraphQL can run on any data source. GraphQL subscriptions can run also on any data source. So it could be on top of, Kafka or Redis or anything like that, or anything that will send an event. And the cool thing about that is not only that you subscribe with an event, you also can attach a query to it. So, let's say I subscribe to an event, I can now enrich the data of the event with extra data with my query. So I can get real-time events, but with all exactly the information that I need to act on that event. I would also add that there's subscriptions and there's live queries. Live queries is a bit different. It's subscription is when I subscribe to event and I get data. Live queries means that I just get a query, and without knowing why it was updating or caring why it was updating, I will get the updated results pushed to me. Mm-hmm. So, if you can think about like a stock ticker or something that you always want to keep up to date, but you don't care why, then that's live queries. And it's not still very commonly used, but now there's a lot of tools that support it. Like on our side, on the guild, we have tools that support live queries, and Facebook has been using live queries for many years. So so that's kind of like the real time part. The introspective part, I think, is also it's very, very important. And I would say, for me, the most interesting thing around introspection is that with OpenAPI, I think we talked about it last time we had the meeting. Like with OpenAPI, you can get introspection. Like you can get a schema or you can get something like that. But in the wild, most likely, like you'll get like an OpenAPI schema, but in production you'll get something completely different. The OpenAPI schema will be out of date. It would be like I think in like 80% of the cases that we see in the wild, that's actually the case. And with GraphQL, GraphQL validates the responses during runtime. So if you introspect a server and you get a schema, you know that this is what you're going to get. Like there's a guarantee that this is what you're going to get. And it saves so much time when you're dealing with any integrations with any other teams, internal teams and outside teams. It saves so much time, just the fact that you validate everything in runtime. I think, that's why I also talked with you about your tool, and I got really excited about your tool because you're also are helping teams that are, let's say, using OpenAPI to look at live data and understand if something is, is different than the actual things, the schemas they have, which is very powerful. And in the GraphQL world, it's almost a non-issue because the schemas are there, and it's very, very So just adding a couple of points to your great summary. Yeah.
No, those are great points, and exactly why we say you live and breathe GraphQL. Okay, moving on to why we should implement GraphQL security. Maybe Ankush, some light on it.
We have. GraphQL has become very, very popular recently, and there have been, because GraphQL is a powerful tool, it has to be used responsibly as well, especially when looking from a security perspective. So here are a few CVs, recent CVs that we found related to GraphQL. Especially the last two over here. In one case, GraphQL subscriptions were not authenticated properly, so any user could subscribe to any other user's subscriptions. And I think the last one, there was no potential authentication. So again, anyone could fetch this context from any user's perspective as well. And this is where and I think all the problems that are there in REST when it comes to security vulnerabilities and security best practices, pretty much all of them are also there in the GraphQL world, although in a slightly different flavor. and that's what we're going to discuss about in the presentation, like in this whole session today. So yeah, we'll see the same kind of vulnerabilities popping up in case of GraphQL, but with a different flavor in its own in its own way, in its own GraphQL way. By the way, I have been looking at the GraphQL plugin ecosystem, and really appreciate how each of those issues are being addressed by a few good plugging in a few good like extension plugins right in the GraphQL server itself. So you will find a lot of fixes which are just like one-liners in GraphQL server. So let's just jump into it.
Awesome. So the topic for today, top 10 GraphQL security checks by Uri. So all yours, Uri.
Thanks. So I'll just say, I think, as you discussed before and you mentioned, I think, like I mentioned before, when I look at GraphQL, and you mentioned like the vulnerabilities are things that, if you're like you're a security person, like you would, and you understand security with REST APIs, like you would understand security with GraphQL APIs. Like there's new things and like new language and queries and schemas and stuff, but basically it's again like automating stuff that happened before. So I think like a lot of the knowledge that you have in other APIs will be beneficial here, how to protect them and how to do things, and we'll go through the examples here. But I think also, as you mentioned, because everything could be automated and declarative, also the solutions, everything is a bit different. So you need to find the right tools also for GraphQL, and that support GraphQL, but the solutions are usually more automated and simple maybe to implement, because again, like you have a declarative way to understand what's going on. So also the tools that secure your API can have more knowledge about what's going on and understand the thing. So I think I would just add another like general point that I think that many people are starting to use GraphQL, and a lot of the mistakes, the security mistakes that they make are actually relatively simple mistakes, where a tool like yours could just flag simple things, and then the solutions are relatively simple and are out there. It's just that people are not super aware of what's going on, and they just build something and it's there, and sometimes in some tools, I would say the defaults are not necessarily super reliable. So that's also why, like in our tools like Yoga and like the Guilds tools, we try to make the default stuff as simple and as secure as possible. But and we try to work with other partners like you and like other security teams to make sure that our tools are following the best practices and out of the box. But some tools are not, and it's good to have a tool that actually runs on everything and gives you that highlight those things. So for the first point here, like disable introspection in production. So like we said before, like if you start a GraphQL server, one of the powerful, you can have so many powerful tools because you enable introspection. That basically means that you can ask the endpoint, the metadata of that endpoint, like what are the schemas that you expose, what are the types, what are the different things. And I would say that like it's a good practice to block this. It's not, I would say, I think there's a saying that security by obscurity is like not necessarily the best thing. So you don't need to rely on the fact that people won't find it out, because there's many tools, and I'm sure yours as well, that like can just go to an GraphQL endpoint even without introspection and understand all of these things. So, but usually, again, if we go through the concepts of GraphQL, those tools are for development. So again, I'll go back to my first sentences that I said, GraphQL is a way for you as a developer to automate things that you're doing with REST. That also means that at runtime, you don't need all these things. So you need introspection as you develop, for your developer environment where developers can get autocomplete. They can use Cogent to generate types. They could do many, many things using this introspection. There's many cool tools like GraphQL, I think you mentioned there, and Cogent, and there's also language services. There's a lot of cool things that are happening now that are relying on introspection, but they're all for development time. So in most cases, like 99% of the cases, you should by default remove introspection and make sure it's not running in production. I think in Yoga Server, this is the server that we developed in the latest version, I think, I'm not sure about it, that is developed that when you're in production, it's disabled by default. But no matter what are the defaults in whatever server you use, you should probably disable it in production. I would add that the 1% cases that you might not want to do it is if you have a public GraphQL API. That means that that you want anyone in the world, and not just the people, not just your developers, to query that API. And they could write their own queries, whatever queries they want. I would say that the use case for public API, there's very few of those. Like you can think of the GitHub public API or Shopify public API. But probably for your use case, you don't need that. And so if you have a public API, it's a whole different conversation. But but the short version is like you say here, try not to expose introspection. And, like you say here with automated check, just, don't rely on just the fact that you removed it once. Actually check in your CI/CD and in production that you're actually not exposing it, to make sure that even if by mistake you did expose it or someone did expose it, make sure it's not there. It's an easy check to add. So,
I have, again, from an operational perspective, I have a question over here. So typically in the REST world, what we can do on the REST API gateway is, block all the requests to Swagger endpoint if they are originating outside of VPC. Something like that, right? So that anyone who has VPN access can actually look at the Swagger file, but anyone sitting outside my cloud or, not connected to my cloud at all can't look at the Swagger file. The same solution would not probably fit in over here because there is a single endpoint. So what if I have to, let's say, have this selective access based on VPN connectivity? What is the best solution there?
So again, if we think about REST and GraphQL just as an automated or a different way to expose REST. So here, introspection is just type of query, right? So what you can do is exactly the same thing. Is you can say you can block any of these types of queries. For example, the introspection query, you can say only in whatever environment these queries are allowed. And these queries are allowed. You can have filters like that. For example, in Yoga, we have a plugin system. So you can write a plugin that just does that, right? That looks the Yoga has a very powerful plugin system. So we can hook into each of the phase. When a GraphQL query comes, you have parsing. So you get the string of the query. Then you validate. You make sure the query is actually valid, and then you execute. So there's all these phases. So you can, with the plugin, go to each one of these phases, and as you, let's say, as you validate the query, you can say, after you parse it, if you see that it's, in a certain environment and it's a certain type of query, you can filter it. And the cool thing is you can then even reuse that plugin. So across all of your environments, or even open source it if you want, if it's a common practice. So again, the same ideas. It's a great question, by the way, because it shows that there is a certain practice that you have in the REST world, and you should do the same with GraphQL. Just instead of thinking about extra endpoints and manual work to do to call them. You have one endpoint with the logic of deciding which query. Like you can look at each query as an endpoint, basically.
Thanks, Uri.
All right. Let's move on to the second one, robust authentication. And I think this is pretty common. I mean, this will go on for REST, GraphQL, gRPC, every API. So yeah.
Yeah, exactly. Like, so, of course we want like good authentication. And again, there's like, we can talk about, the differences. And again, this is true for REST and GraphQL about authentication and authorization. But usually what we want is, if we look at, let's say, again, the phases of things, we get a query, and then GraphQL needs to do the automated work, which we maybe before did manually, of calling different endpoints. If we look at like how we would do it manually with REST, we would get the request. We would first authenticate the request, meaning like we're going to see first who is it, because we need, based on who is it, we need to know if they have access to which one of the services we're going to call. So we're going to get the information of who is it. Once we get that information, we attach that information to all the different requests. And there we make sure in each one of these requests or each one of the other services we're calling, we're going to make sure that the user actually, that specific type of user actually has access to all these different things. With GraphQL, it should be the same. So I think there's a lot of questions around it in GraphQL because theoretically you can handle it. There's all kinds of tools, for example, that lets you define authorization rules with directives, and people get confused. I think here, again, the same practices, if you bring the same practices from REST to GraphQL, you're going to be okay. You want to authenticate with this. Usually when we do migrations, let's say from REST to GraphQL, and there's a certain service that is responsible for authentication, we're not changing that service at all. Like what you see here, like in the context, like you get the request, we attach to the, let's say the request headers, the authentication result, and we're using the same authentication service we had before with REST. There's no difference here. We just attach it to GraphQL and then sending that to the execution phase, where in that execution phase, it will call different resolvers, which means different logics for accessing data, and those different resolvers will have that information with them. So anyway, like all the stuff that you wrote that is written here is true. And again, like you will start the authenticating before you do all the GraphQL execution. And then I would say even, I think even a better practice is not necessarily like one way is actually what you see here, that like in the resolvers you block it if the user is not authenticated or if the user is not like, let's say, but sometimes all you do in the resolvers is call another service, and maybe you actually prefer to handle these in the services. Right, so the services themselves maybe should block as well any requests that are not authenticated, and then also do authorization. When we get to authorization, we'll also talk about that and where it should live. But yeah, maybe you want to add all more stuff on the right way to do authentication.
Yeah. So we have a little bit of, I think there's another check coming for authorization. This was authentication, but probably next we'll go, so we'll see. Okay, limit query depths.
So around limit query depths. So I would mention here something I think very important that I would say this is again almost like disable introspection, something everyone should do during production, when they go into production. Except public APIs, which we'll talk a bit about at the end. So A lot of people, they look at GraphQL as now anyone can send any query to the gateway, and that's not how all the main GraphQL companies, all the large GraphQL companies are actually doing it. When the large GraphQL companies are doing it, again, they're using GraphQL as a development tool. So in development, you can write all kinds of queries. Your own developers can write any queries that they want. But then as they go into production, what's happening is that they run some build process that runs through all the client's code. The client could be an iOS, web, whatever, or other services that call GraphQL, your service. What they then do is they take all the queries from code and convert it into a hash map, and basically an allow list. So now on the server, this is called, the name of it, if people want to Google it or find it, it's called persistent queries or trusted queries. So what happens then is that on the server, you're going to have an allow list of just the queries that were actually being written by your own developers in development time. So that means now, if someone will send an arbitrary query to your GraphQL server, it will get blocked automatically without doing any parsing, anything. And that's, I think, something everyone should do. Like, the interesting thing is almost not a lot of people are doing it, like, unless they get into like really, I don't know why. I think it's really important. Because if you do that, then the biggest risk of what we're seeing here, let's say limit query depth, is gone, because it's your GraphQL server automatically blocks any query that is not the queries that you already know about. So it's not like random people can just send like very, very long queries. And like you said, send a query that is so big that can do a denial service to your API. So, this will be, I'll repeat this thing almost on every slide here, because I think it's such an important thing and people are missing it. Use persistent queries. Use trusted queries everywhere you can, unless, again, you do a public API. Now, let's say you do have a public API, or let's say you're not trusting your own developers, right? Your own developers might write like too much of a bigger query. Then what you want is to basically have a tool that limits how deep the query could be. Because theoretically, if we're going to have like tons and tons of like a very deep query, it means that we'll call many, many different services again and again and again and again. And we don't want that. So there's different tools, like one tool that like I would highly recommend for everyone to read and go through is, in the JavaScript world, is GraphQL Armor. And there's also an equivalent of that. I think on the Guild's blog post, we're going to publish an equivalent of that that's written in Go by another someone from the community. I'm not sure it's already live, but probably in a week or so. But our blog post is also open source. So if you already want to read it, you can, once the PR there, it's already kind of ready. But these tools, what they do is they go look at, let's say, a query that comes in, and they just parse the query to see how many depth levels they are. And they could limit, like exactly like you see the example here, they could say just the depth limit of 5 or 4. And otherwise, it will block everything. So this is something that is very good practice to do. And again, the higher priority than this is to do persistent queries. But because most likely that if you do persistent queries, it would greatly reduce the risk of having very deep queries. And I will say again, so many people would look at this and they would say, oh, so GraphQL is a security risk because I can write a very deep query and to do that. But if you think, again, like we went from REST to GraphQL, you could do the same with REST, just you would have no idea, because people can just write the code that will, call your endpoints a lot. Or if we're talking about your own developers can write a controller even without noticing. Like, let's say they would do a for loop without missing something, suddenly you would get like something equivalent of a very deep query, but you would have no idea because it's encoded, it's so declarative. So the cool thing about GraphQL is that you could actually detect these things easier. And you could, just by looking at the query, just from parsing the AST with GraphQL Armor or other tools, you can identify those things. So I would disagree with people that would say that GraphQL is a security risk, because this security risk also, again, exists in REST, and it will be harder to detect. And if you're using persistent queries, it just blocks anyone else to actually be able to do that. So yeah, I talked a lot about this, but it's a subject that I really care about, because there's a lot of like misconceptions about GraphQL. And the biggest one is that it's not secure or something, but all the biggest companies in the world are using it. So it's important to explain why.
Yeah, totally. And in fact, like one of the big advantages, queries are so unlike REST, where the query is embedded in some code. Here, the query is like very, very transparent. So, and there are like many good plugins out there that analyze the complexity of the query and then block the query if it's like way too complex. So a good complexity analysis tool, which is, I'm sure, like, many good plugins are out there, plus a simple validation, like a strict depth check. I think that's a great way to ensure this doesn't happen in production.
Yeah, and also I think probably because of that, for tools like yours, it's easier to detect if an API is actually blocking it or not.
Yeah.
So otherwise, with REST, it's just an endpoint. Here, you can probably easier and alert people with GraphQL better.
Yeah. Awesome. Moving on to the fourth, since we have 7 more left and we have 20 minutes, probably in we'll move on a little faster. Yes. So rate limiting.
Okay, I'll try to go faster, but like if not, people can reach out to me, or we can do another one of these again. Like I don't mind, I would love to. So rate limiting again. Someone can send a lot of number of large requests over similar queries. And again, you can take the same in REST, right? Like with REST, you can just pick an endpoint and bomb it with as many things as possible. So the same thing here. Here you can see like an example of a poll server, but actually in Yoga, we have because of our plugin system, it's easier to block. Like you can actually, there's GraphQL Armor, again, the same library I mentioned, that will help you block it. So again, this is extremely similar or even identical to the same thing that GraphQL, that REST is doing. Just instead of thinking endpoints, you're thinking queries, and you're doing the same logic. And there's tools to help you around it.
Awesome. So the fifth check, input validation. Again, the most common check for REST APIs as well. Yeah.
Yes. Same thing. Like you can think a query as an endpoint, and a query, or in this case, a mutation, which is kind of like a post request to change data. You would have parameters, and you would want to input validate them. Same thing here. Exactly the same logic, exactly the same thing, just parallelizing it to REST. And again, because here everything is is around the schema, and you can actually and the schema actually tied to the actual execution and the runtime, it's easier to identify when you're not doing it using tools like yourselves, and then to take care of it.
Yes. All right. Sixth one, secure direct object references.
So
authorization checks, we talked about authentication before, but this is kind of authorization.
I see. Yeah. So here, if I understand correctly, what we mean is that you don't want to give unauthorized. You want to make sure that not unauthorized people can have access to a certain resource.
Yeah.
I would say that here, I would think it's related to something I said before. I would look at GraphQL as a router, as an automatic router that does the logic that you do in the controller. I would think that like in best practices in REST, you wouldn't want to do authorization you wouldn't want to count on the authorization you're doing on the controller. You would want actually to be the authorization to be as close to the service itself, because authorization relates to the business logic, right? So if you have an events service, probably that service knows best which types of users have access to which things. And that means that even if the controller or the endpoint, the REST endpoint would call that with an unauthorized user, you want to make sure that the service is actually blocking it and doing it. So here as well, like I would first of all encourage authorization to sit as close as possible to the business logic. If you're writing, your business logic in your resolvers, then again, you make sure you have this snippet here that you have to make sure that like the user actually has access to the right data in here. But I would say that this is like a simplistic way of writing resolvers. Usually, you write the main business logic in another service or in an encapsulated class. Like we have a tool that's called the GraphQL modules. So you write different like business modules, and from the resolvers you call the right modules. And in those modules, that's where you make sure you write the business logic and you make sure that you do authorization in the right way.
Yeah. So correct me if I'm wrong, or maybe so at least in the REST world, a typical practice is you always prefix the admin APIs by saying /admin. So my API looks like /admin and then some operation name. And I think that's what you're referring for GraphQL modules as well. So there should be a separate admin module, and if there's a call happening to that admin module, there probably that's the best place where the admin check should happen.
Yeah, I think so. In GraphQL, it's a bit more complex, or I would call it in a better structure, because maybe it's admin, but then maybe you have many different other users, right? Like making it to a regular user and an admin is not necessary. There's many different levels of users. There's a homeowner and a renter, and depends on the business logic. So in GraphQL, you can indirectly get to, let's say, to home or to the home service in many different ways, right? Like you can have here the user, and you see the user's posts, but maybe you have another query which is give me all the posts as an admin. So you would want to have the authorization logic in a place where no matter how you get to posts, you go through that logic. Yeah. So that's why it's important not to write it in the, let's say, the root level queries, but actually you make that logic in the resolvers of the types themselves, or better so in the right modules or in the services themselves.
Yeah. Thanks, Uri.
All right. 7th one. Error handling, again, similar for REST APIs as well. Yeah.
Mm-hmm. Yeah. So again, when there's an error, an unexpected error, you want to make sure that you're not exposing something that maybe gives too much information for people about what's actually happening under the hood. So first thing is, we have in Yoga, for example, we have a default setting for it, and also that's enabled by default, but also by default we mask errors, and then just general errors that are not from the errors that we actually know. We do create GraphQL in our GraphQL schema for all the errors that we know about and we anticipate and we want to expose to the users. We actually add them to the schema. So we add let's say user is too young, error, right? And because we expose it into the schema, that also means that the clients, they can read the schema as the developers. They can read the schema, anticipate the cases that this will happen, And actually, like, let's say TypeScript, or if they use Cogent, will warn them if they haven't actually, made the case to handle this error. So these are the errors that you want to expose to the user. But if you have the right, server implementation, and if not, you should make sure that you have is to block all the errors that are not that, not the errors that are you want to expose to the user. Everything else is just blocked by default by your server. Yeah.
Uri, could there be a case where the server itself like produces an error and like returns it as a response by mistake?
Yeah, so it depends on your server implementation. Again, like in Yoga, we automatically block it. Here, I see like, you can create a function, to parse and handle all the GraphQL errors in your application. In Yoga, we automatically do that. But so anything that you haven't declared to us, like we would block. But and again, in production, in development, we will send it. So, but you have to make sure, like it's something again like that. With tools like yours, you can make sure that you haven't, that you can actually test it and make sure that you've done it. But some tools are automatically blocking it and are more secure, like Yoga, and some tools are not.
Got it. Yeah, I mean, it's either a reactive or a proactive approach. Ours is more, like test it in CI/CD and know if there are errors are being, and then reactive will be actually block it. So yeah.
Yeah.
The next one, query complexity analysis. What's your thought here?
Yeah, so I'll go with like again the original thing that I said about persistent queries, right? Like first thing, make sure that like if you're just writing a query to your GraphQL server and that all those queries are by your developers, block everything else automatically. So then all the queries in advance, all of these things. Now, complexity is interesting because the main question is, it's kind of like the idea is like, so you can create like if for a specific query and for specific types or fields or resolvers, what actually costs more? Like what is complex? What is considered complex? It's not only the depth of the query itself, it's also how much you give pricing, let's say, to each one of the fields. So there's many ways of doing it. Usually you can, so again, in GraphQL Armor, for example, you can configure it. I think GraphQL Armor, I would say, is the best tool out there for this. But again, there you need to define what, how to calculate complexity. A good way to calculate complexity is actually to look at how much each resolver, each type, or each field takes when you run it in production. Let's say if fetching the author takes like, a second, and fetching the title, takes like a split second, then you want to calculate it in. This is where like tools like, like Hive, for example, they go into like, they give you an analysis of in production, how much everything is cost. And then you can get that information into tools like GraphQL Armor and define them like that. So, so you can do it manually and you can adjust with time, but yeah.
Uri, we have a few questions in the chat, by the way.
Q&A. Somebody has asked, what are the best libraries to use to make it easier for me to implement and adopt a production-grade security for my backend?
So I would say for in the JavaScript ecosystem, that's where like kind of like we are in mostly. I would say, and again, I'm biased, but like also at the Guild, we don't mind using other people's tools. We only develop the tools when we see there's a need for the community. So we developed Yoga Server because we thought that like there was a need for it. So I really think that if you're in the JavaScript world, a Yoga Server is the best server. We also have a comparison table on the website that compares Yoga Server to Apollo Server and other servers as well. both in performance, in features, and security, and all of those things. So if you ask me, and again, it's a biased answer, it's a Yoga server, GraphQL server, GraphQL Yoga. And when it comes to security, I highly recommend, first of all, persist the queries. Do it everywhere. And that's not like a tool. It's just a thing you should do. And with Yoga, it's very, very simple to integrate. And again, not APQ. APQ is another thing that I think is a mess. So it's like automatic persistent queries. That's actually a bigger security risk that I think you shouldn't use. Persistent queries or trusted queries, the original ones, these are the ones you should use. And also use GraphQL Armor. I mentioned it again. And there's a couple of equivalent, like in the other ecosystem. So I would look at how Yoga is doing it and how GraphQL Armor is doing it, and I will try to find the right implementations for it in the other languages. I think you would probably find everything there. I think we have also a couple of security guides on our website. I think on the Yoga website, but I'm not sure. I would look it up somewhere here in or on our blog. We have some notes about that. So yeah, I will share later on links after the call.
Awesome. We have a couple of more questions. Maybe we can take it a little later. We'll just finish off this and then maybe questions time. Awesome. 9th one, mass assignment.
So what's the idea here? I'm not sure actually. Let me read it.
Ankush, you can start with.
Yeah. So here, because again, like I think I know your answer is going to be persistent queries, but essentially what happens here is because the query structure is very, very flexible. Let's say there is a mutation endpoint which updates the details of a user. I mean, practically, you wouldn't send email ID as a field to get updated, but a malicious user can actually send email ID as an update in the mutation, and it actually executes as well. In the rest world,
I see.
Make a whitelist whitelist of inputs that can come in. The rest will just be ignored. But I would love to learn what you would suggest in the GraphQL world.
I see. So if I understand correctly, so if there's like an update user mutation, the risk here is if someone sends in the input too many fields or something like that. So I guess it's exactly the same as REST, right? Because it's a mutation is exactly like a post endpoint. So we said before you want to validate the inputs first of all to see that there's no harmful things there, but also it's just like a post endpoint. If someone is gonna send too much information there, it will translate into a crazy SQL, insert object or something like that. It's the same thing. So again, same ideas from REST to here. It's just a post request with an input. That's a mutation. That's basically that.
Awesome. So we are at our last one, which is excessive data exposure. It's a simple one.
So Uri, this is also like the last one. Instead of a mutation, we are dealing with a simple query over here. So instead of querying just the name or title or content, I can also try and query some PI data like your social login token or your email ID or your address by just adding in one extra query field.
Yeah, I see what you mean. So basically, let's say you have an endpoint and you wrote an app, and the app just needs the title and the author. But then, because let's say for whatever reason your GraphQL API can expose more fields, those fields could be queried. Like for example, a token that you don't want to be publicly exposed and things like that. This is it's a very good thing to talk about, and I think. First of all, automated tools are great here. Basically, it tries to query everything and identify. And I saw your tool is actually doing it, which is really cool. trying to identify tokens and things like that by mistake are being exposed. I think as general practice, there's a lot of really cool tools, for example, that automatically translate, let's say, a database or a data source into GraphQL, or GraphQL Mesh, which is our tool that takes like a REST API and automatically translates it to GraphQL. These are great, but you should anyway. Let's say in GraphQL Mesh, we do that translation at build time. Why? Because for many, many reasons, but one of them is that you can then review the resulted GraphQL schema. So you can make sure that, like, first of all, you can make sure that nothing that you don't want to expose will get exposed. And if it does, and you want it to get exposed, you want to make sure that you have some logic, like what you wrote here, that the right users or the right will actually have access to it. There's also, by the way, tools to filter the schema according to different users or according to different things. I mentioned Yoga's plugin system. That's also because we hook into all the different phases, we can actually even hook into the introspection phase and then send you the introspection according to the right user. So you wouldn't even get, in introspection, you can filter it, or even in execution, you can filter it with the right plugins. And even in Hive, let's say in our schema registry, we have a thing called contracts, which like you can take, let's say a bunch of APIs, and then you can create a contract, which is basically, you can just decide which fields are being exposed and which not, and for which use cases. But yeah, I think anyway, the critical point here is you want to make sure you have some kind of check to make sure that you're not exposing fields that are not authorized for everyone by mistake.
Got it. Awesome. So these were our 10 checks, and just a little bit of summary of what we went through. I think I can skip these slides and go to our last section. So guys, we are over time, but I'll just cover it in 2 minutes. So how Akto can automate GraphQL security? You saw all of these 10 security issues that can occur once if you're using GraphQL, or actually REST APIs as well, any kind of APIs. So Akto is an API security tool. What it does is essentially these things. Firstly, it will automate your API discovery process. So in GraphQL, it's much easier. For REST, it's quite harder. So anytime you deploy Akto, you will see all of your APIs discovered in a real-time automated way. Second, we discussed about sensitive data exposure. That's exactly what Akto solves for. Akto will tell you what all sensitive data is passing in your request and response, be it SSN, credit card number, phone number, email, anything, Akto will detect automatically. Third, we do all API scanning. I've mentioned GraphQL over here because we are at the topic of GraphQL security. So Akto automates GraphQL API scanning with complete OWASP top 10 coverage. The other things are you can add your custom test in very simple YAML formats and actually put all of these testing in CI/CD. So you don't have to worry about it before every release. We have about 20 plus connectors, most famous being Kubernetes. If you want a demo, actually, I'll send a link over here. But yeah, let's connect for a 15 minutes demo. I will just share with you a demo link. Actually, you can go to the website. And here you go. All right. We have a couple of questions. If people have time, maybe we can address these. So one question is from Ayush. What does complexity limit denote exactly in this example? I think he was talking about this example. Yes. So I think he's talking about this.
Yeah, so I think maybe the question is like, what is 1000? What does it even mean? Yeah. So I think that's exactly what I mentioned when I said it's hard to define complexity, right? And also for different servers, they have different complexity just by their regular usage, right? Like some servers, they serve static data. So for them, complexity should be very, very low. So it's not like a quantitative thing. That's why I think in order to define this, you have to actually measure your server, and you actually measure like how much resolving or the runtime performance of your server is, and then define according to those what are the limits that you think are reasonable. That's why I think all kinds of tools like GraphQL Hive is good to have, and actually measuring it you don't need GraphQL specific tools. You can measure it with like Datadog or any like open telemetry or whatever. But just understand, what are the limits that are good for you, and then define those, and then define the right complexity. Because the complexity thing will take all those different fields and will calculate per query how complex it's going to be. Because it will understand, with this structure of query, how actually it's going to get executed more or less before it's even executing it. That's the goal. That's the idea, to measure the complexity before the execution. There's more, I think, data about it on GraphQL Armor website. So you can go to GraphQL Armor and maybe on your website as well, but and then read about how they calculate it exactly, what algorithms they're using.
Got it. There's another question about, and this is an interesting one. So if you're using a public GraphQL API, how can we, as a user of the API, see that our data is secured? So this is not from a
as
developer.
The user?
Yeah, as a user, it's probably hard.
I think it's hard. I guess what you can do is try to use some tool to try to hack the system and understand. I mean, it's the same as a REST. It's not like if you have a REST endpoint, how can you know if it's secure or not? You run some tool to try to do some things and see what the results are. But just as a user, there's nothing, I think, you could maybe guess from the schema and from all the stuff that we just went through today, if those people are actually working with the best practices or not. But if they're not open source, then probably a tool, let's say like Akto, you can run it on that endpoint and see what's happening. I think there's also all kinds of tools that you can run on public endpoints, and we can try to give you some information about if they're if they're using best practices or not. There's a couple of tools like that, I think.
Yeah. Another thing that you can do is, people do it whenever they're buying a vendor product, they kind of do pen test on that vendor product itself. So that's also one way. But it's harder to know if the GraphQL API that you are consuming is actually secure or not. Awesome. So this is the end of our webinar. Wonderful, wonderful webinar. Thank you so much, Uri, for being here. One thing I think we should take away from this webinar is use persistent queries. I think that's one key takeaway.
I think yoga and this whole extension, its whole plugin ecosystem, I think it's really, really mature. I'm definitely gonna give it a try next time I build a GraphQL.
Yeah. Persistent query.
Thank you very much.
Awesome. Thank you. Thank you so much, Uri. Thanks, guys. Thanks for being here.
Bye.
Bye.